right, guys. So we were being asked to first use a calculator to help you complete the table below. So what did you figure out you had to do here to figure out what was missing in our chart?
Just plug it in.
Plug what in?
Into the blank power.
Yeah, so here, this 10 to the first power, we got this number by doing 1 plus 1 over, what's our new n? 10 to the power of 1, which is just what?
10.
10. And then the whole thing raised to what power?
10.
Oh, and look, it gives us 2.5937, which can round to 2.594, which is exactly what they got. So then you plugged in 10 to the second power, which is 100, and what did you get? 2.7 to the hundredths place, I would like it.
Oh, then that'd be 1.
2 point what? 7.1. To the, guys, where's the thousandths place?
It's 3 points past the decimal.
Okay, so 2.70. Beautiful. And what did you get for the next one?
2.717.
2.717, yes. And next?
2.718.
And then?
2.718.
And then?
2.718.
Weird. So is this approaching a fixed number?
Yes.
Yes. Technically in your calculators, were these numbers exactly the same every time?
No.
No, it was changing, but it was changing by a bigger or smaller amount every time? Smaller. So this is similar to approaching a what on a graph? Yes, okay. So each time, and we're just going to do to the thousandths place, each time this is approaching the number 2.718. Guess what? That is Euler's number. That is a natural number that comes up many times in nature. Now, how they discovered this number was not by saying, oh, 1 plus 1 over n raised to the power of n, what is that each time? No. What they did was they took 1 over 1 and they added it to 1 over 1 times 2. And they added it to 1 over 1 times 2 times 3. And they added it to 1 over 1 times 2 times 3 times, whoops, not plus, times 4. Now, for each and every one of these, are these numbers getting bigger or smaller?
Smaller.
Why smaller? Because the number in the denominator is getting what?
That's what I meant. The denominator is going to be.
So each time are we adding less or more? Each time we're adding less and less and less and less, meaning eventually this number that's going to be added on is extremely close to which number? 0. So each time, if we go far enough out, far enough, this is how they are approaching the number 2.718. And like it says below, this number is mainly used to deal with compounding interest continuously. Now, recently with interest, have we been continuously compounding it?
No.
No. What have we been doing?
There's like a certain time limit.
Right. What is the normal time that we've been dealing with?
1 year.
1 year, right? So we have been compounding interest yearly. This is how we go about compounding interest continuously. Now, that's not going to be today that we're going to do that. We're going to do that
Next week.
next week. Thank you, Miss White.
Got you.
Now, if E represents a natural base, so this is called a natural base, right? This number was found in nature. Then what other function aside from exponential will be affected by this?
Log.
Why log?
Because it's the inverse.
Yes, and E is a what? What is E?
It's a big.
It's a base, yes. So we can take log of base E. Now, if E is called the natural base, what do you think log of base E is called?
Natural law.
Oh my God, it's the natural log.
For real?
Yeah, and guess what? They denote it by ln because these are the initials of natural log, but they switched the L and the N because it's a log still, so they wanted to put L first. So ln denotes the natural log. It means log of base E. Now, lucky enough for us, our calculators have a shortcut. Rather than putting in, hitting math, and then up to log base, and then putting log base E, instead of doing that, what do you notice on your calculators?
LN, right under.
Oh my gosh, there's an LN button.
Whoa!
There's an LN button. Do you see where it is?
Right under log.
And where is the E button? There are two actually we can use.
There's second divide.
Second divide, which this is the E that you use when you don't need an exponent on it. And where's the other E?
It's the same thing as the LN.
Ah, second ln. This is when you do want an exponent on the E. Okay, so you can use either one depending on if you want an exponent or if you don't. Now, I want you guys to try to go ahead and do five. Try to do, all of number 5. Now, if it says, so this one's easy, you can just put it in the calculator. But if it says here, C, ln of x equals 4, what is ln the same as?
Natural log.
So what can I rewrite this as?
Log X.
ln has a base of E. So now we for sure know how to solve for x. How do we do this? Yes, we have to unlog it, right? Start with the base and roll around. So this becomes E of 4 is equal to x. And then of course you have to get the actual answer here. Any questions?
Yes.
Well, try it first. What
Leo.
did you guys get for part A?
No, it's not about.
4.277.
4.27. Good.
Okay, look,
What about
right
B?
here. I did
Oh,
myself.
good. What about part B? Yes. And part C? Yes, 54.60. And D? 1.95. And E? 3.20, yeah. And F? Yes. And G? Did we get to G? Yes, 1094.63. And H? No. No. So on this one, first we have to get the ln by itself, right? It's still a log. We have to get it by itself before we roll anything, right? So we're going to subtract the 3 over first. And I have 2 times ln of x is equal to 4. Is the log by itself yet? No, so what should I do? So it's ln of x is equal to 2. Now what can ln of x be rewritten as?
3.
Log base E of x is equal to 2. So now I'm trying to get the x to be unlogged, so I log roll from the base of E around. So it's E raised to the power of 2 is equal to x. So I plug that in my calculator and I get 7.39. There it is. Any questions on any of these?
Wait, is this stuff is on next 6 weeks, right? We're starting off
F and G. So here first I have to get the x by itself, so all I have to do is subtract 5 over. So all I'm plugging in my calculator is e raised to the power of 3 minus 5. You don't have to log roll at all. All you have to do is subtract 5.
Why do you have to log on the next one though?
On the next one, do we have the log by itself?
No. Yes.
Yes, you do, right? This whole thing is being logged. So we do have the log by itself. So how do I get an x from being unlogged? Log roll it. So this is log base e of x plus 2 equals 7. So I started my base, I roll towards the equal sign and around. So this is e of 7 is equal to x plus 2. But then to get the x by itself, I had to subtract 2. And that's what I put in my calculator.
Is it English? Yeah, not good.
Any questions there? Is this making sense?
Yep.
It's really just a special circumstance of log and exponential, right? It's just a special e. All the same rules apply. All right.
All them reds.
What's that?
Is it
E
Yeah.
is 2.718. Oh, E. Oh, not the E. 3.20, I thought.
Yeah.
Because here you have to log roll. You start with your base towards the equal sign. So that's log base E of 9 is equal to x minus 1. You add 1 over. So this is ln of 9 plus 1 is what you put in your calculator.
Do you not like add it to the 9 to make it 10?
No. Only the 9 is being logged. This is our log. Good question. Once you've already log rolled, you can't add something onto your log. Does that make sense?
Mm-hmm.
All right. So on the back, you're going to like this.
What the heck is going on?
On the back.
We're gonna like this.
You're going to like it. What I want you to do is I want you to figure out how column A compares to column B. I want you to type in your calculator log of 30, and I want you to type in your calculator log of 5 plus log of 6, and then I want you to say if it's equal to, greater than, or less than.
Okay.
Log of 5.
This is good log practice.
Now, yes, it's good log practice. Now, all you have to do is type in just this log. Whoops. Log, and what base is that if I just type log? 10. Yep, so just type log for each one. Log of 30. And then figure out, is that equal to, greater than, or less than column B? Do that for each one. All right, guys, so log of 30 is what to log 5 plus log 6? What are they? Equal. What about log of 27 to log of 9 plus log of 3? So, looking at this, if I have log of 5 plus log of 6, what is 5 to 6 to get 30? What did I do to 5 and 6 to get 30? Multiply. So that is our very first log rule, that when I have two things multiplied together in a log, I can split them apart by adding them. So log base b of m plus log base b of n is the same thing as log base b of m times n.
What?
That looks too complicated than what I did. I don't get it.
Plus. Oh, it's a plus. Okay. It's not in here.
Did you put it in there?
No, because I remember putting in the.
Let me check through it.
Okay.
And then we had log of 24 minus log of 3. How did I get 8 from 24 and 3? How do you get 8 from 24 and 3? Oh, you divide them. So when you're dividing two things, you can split the division up in a log by subtracting m log base b of m minus log base b of n. This is the second log rule.
This is opposite of exponent.
Right. So just like we have exponential rules, we have exponent rules, we have log rules. Now, what do you think here when we have m raised to the p power? Where can that p go? In front. Whoops, that's a b. And then if I have log base b of m set equal to log base b of n, what does that mean m has to be to n? They're the same. M is equal to n. Now, what do you notice about each and every single one of these? What do they all have the same? And base b. In order to apply these log rules, they must always have the same base. So let me get you started. If we have log base 6 of 4 plus log base 6 of 2, how can I rewrite that?
12.
Log base 6 of what? Yeah, 4 times 2 is 8. So then you guys try to do the rest B through D.